So question number 11, they like asking this question. This logarithm question. You said for a gas PV raised power gamma is equal to C. If log P is plotted against log V, the intercept and slope are. We'll just do what we did in the other question. So we'll log everything. That's log bracket PV raised power gamma is equal to log C. Right? Then we open the bracket, that's log P plus log V raised power gamma is equal to log C. That's it. So we can also represent this as log P plus gamma log V. Gamma log V is equal to log C. So we want to write this equation in a way it resembles equation on a straight line, and that's y is equal to mx plus c. That's y is equal to mx plus c. So how do we write it like this? They said log P is plotted against log V. That means log P is the y-axis. That's log P plotted against log V. As log V is the x-axis. So we bring this log V, we bring it to the right hand side. That will be minus gamma log V. And minus gamma log V, then plus log C. Then plus log C. So they're asking us what is the slope and what is the intercept. We write this stuff back. Y is equal to mx plus c. This is the y-axis. This is the v is the x-axis. The slope m is equal to this. So our slope m is minus gamma. Our slope m is minus gamma, and our constant c is all of log c. Note that our intercept is all of log c. Note that our intercept is not c, it is log c. Everything is log c. So the right option is option C. That's the right option. The right option is option C. Question number 11. Question number 12. Measurable quantities are grouped into. As simple as this question is, a lot of people can still miss it because it is not something most people pay attention to if you are reading the slide. Measurable quantities are grouped into two, and those are fundamental quantities and derived quantities. That's all. So measurable quantities are grouped into two. Measurable quantities are grouped into two, and that's to remind you that fundamental quantities we just have 7 fundamental quantities. Most other textbooks might be reading different things, but here we just have 7 fundamental quantities, and measurable quantities are divided into 2. Fundamental quantities and derived quantities. Fundamental quantities is 7, derived quantities is the rest. So question number 13. Which of the following statements is false? They said physical quantities are also known as dimensions. False already. We need to go for that. Physical quantities are also not known as, they are not known as dimension. Dimension and physical quantities are two separate things. Option B, say all units of the same dimension are related. Yes, we've explained this. Dimensionless quantities do not have units. Dimensionless quantities not all dimensionless quantities. Some dimensionless quantities have units, like angle has units, but it's dimensionless. So they say dimensional quantities do not have units. Frequency has dimension of period of this, and cycle is dimensional. Yes, but the answer is still option A, because physical quantities are not known as dimensions. So physical quantities are also known as dimensions. No. But yes, dimensionless quantities, some dimensionless quantities does not have units, so that one can be almost correct. But if you say all dimensional quantities does not have units, then you can say that option 2 is false. So let's go to question number 14. It said giving x is equal to et squared. x is equal to et square. We are seeing the board here. X is equal to et square plus f, and y is equal to ht square minus t, and z is equal to gt square plus g. And I said find the dimension of E, F, and G. It says you find the dimension of E, F, and G. So how do you find the dimension of E, F, and G? So how do you find the dimension of E, F, and G? You use principle of homogeneity. F, we all know x, y, and z are x, y, and z. The dimension of x, y, and z is length. So this is L. So to find for f is very easy to find. This is separated by is equal to x is equal to this is equal to. So it's separated by is equal to x and f. They are separated by is equal to. So x is equal to f. And if x is equal to f and the dimension of x is L, and the dimension of f is also L. So we've gotten like that. As you've gotten the one for f, as a smart student, the first thing you do is to check the one that f is not L, eliminates the option. You'll be left with some other options. So let's do for E. Where's E? J2 is also L. If you look at it, F is L and X is L. Let's look for E. So E, you say x is equal to et square. X is equal to et square. So E will be, and the dimension of x is L, E will be x over t square. That's L over t square, and that's LT raised to power minus 2. That's LT raised to power minus 2. That E is equal to LT raised to power minus 2 L. So the answer is between A and D. The answer should look for G. So you should look for G. This question you should look for J. J is supposed to be L also, because Z is L. Z is L, right? It's supposed to be L. Or is it H they are asking for? But J is equal to L. J is also equal to L. I think the question is not complete, or there are some irregularities. But J is equal to L also. J is equal to L is LTS per minus 2. E is LTS because J is equal to L, this is it. E is equal to L is per minus 2, and F is also equal to L. So let's move to the next question, so no waste our time. So question number 15. Two forces 10 Newton and 15 Newton act at 30 degrees. Find the resultant. So this one is acting, this is 10 Newton, let's say this is 10 Newton, this is 15 Newton. This is 10 Newton, this is 15 Newton, and they are acting at 30 degrees to each other. That's not 30 degrees to each other, so this is 30 degrees to each other. So how do you find the resultant? We just use the cosine formula. R square is equal to a square plus b square. You can use plus because the angle is between the two vectors. I've explained this in a video I made on geometrical method. Plus 2ab cos 30 degree. So if you plug in the values, that will be 10 square plus 15 square plus 2 bracket 10 bracket 15 cos 30. So let's just get the answer. 10 square plus 15 square That's 325. 325 plus this will be 300. So 300 cos 30. 300 cos 30 is 259 plus 259.81. 259.81. That's good. So let's square both sides. So our final answer of R will be as 259.81 plus 325. 259.81 plus 325 square root of answer. That's 24.182. Using the option 24.182. So what is 24.18? Yeah, so that's the answer. 24.18 Newton. 24.18 Newton. So that's the answer of question number 15. Question number 15. So question number 16. I'm going to change this chalk. So question number 16 now. They said if F1 is 4i plus j, F2 is 3i plus 2j, and F3 is minus j. So if it's minus j, what do you put as I? That will be 0i minus j. So that's 0i minus j. I've explained this thing in a video I uploaded on analytical method, how to resolve using analytical method. So they say find the resultant magnitude. It's very easy. If they say find the resultant magnitude, you see that in these options, there are options that are having I and j, and there are some that are having the value. So then you see that you go with the option that has the value, not the one that has I and j. The one that has I and j is incomplete. So the first thing we do, the resultant first, we add everything together. If you add this and this, you get 7i. That's 4i plus 3i plus 0, that's 7i. If you add all this together, that will be, if you add all this together, that will be 1 plus 2 minus 1. That's 2. Am I correct? 1 plus 2. That's 3 minus 1. Yes. That's 2g. That's 7i plus 2g. So we won't leave our answer like this. We represent it in a value. So what do? The resultant, the magnitude now be the square root of 7 squared plus 2 squared. The square root of 7 squared plus 2 squared. And that will be on calculator. Square root of 7 squared plus 2 squared. The answer is 7.28. That's 7.28 Newton. 7.28 Newton. And that's the answer. That's option A. So mind you, that's question number 16. So the answer is option A. Mind you, if your answer is left like this, and you see this one, let's say this one is option A, this one is option B, and they say find the result, the magnitude. They say find the resultant magnitude, as magnitude of resultant. Don't go with this one at all. Instead, go with this, because this is the final answer. This is this. When you say okay, they've not brought it out like that, but if you say okay, if you represent it in unit vector, you say find the resultant or the magnitude in unit vector. Okay, you can leave it like this, but most times just say find the resultant or the magnitude. You see this in the option, you see this in the option, you go for this one, not this one. So don't leave the answer in this. This one is incomplete. This one is okay. Let's go to question number 17. It said two insects have velocities VA. VA is equal to I minus 4J. I minus 4J minus 3K. And VB. VB has 4I plus 2J plus 4k. Now say find the distance after 2.5 seconds. That time is 2.5 seconds. So find the distance. You all know the distance is force times velocity. But before we use this formula, we need to find the resultant velocity. And to find the resultant velocity, since it moved from one place to another, so the resultant velocity just be like relative velocity. That will be VB minus VA. And if you do VB minus VA, that's 4I minus I, that's 3I. 2J minus 4J, that's plus 6J plus 7J plus 7K. 4 minus 3 plus 7J. So after doing that, we find the resultant. So this is just square root of 3 squared plus 6 squared plus 7 squared. Let me do that. Square root of 3 squared plus 6 squared plus 7 squared. That will be 9.69. That's 9.69. That's 9.69 meters per second. But we are looking for distance. Oh, sorry, this thing just. So we're looking for distance. We've reached here. So we're looking for distance. So that's velocity times time. That's 9.69 times 5. That's 9.69 times 5. So after getting this, we look for the distance. That's velocity times time. So that was 9.69 times 2.5. Sorry, not 5, 2.5. Times 2.5. So our final answer is will be 9.69 times 2.5. 9.69 times 2.5. And that will be 24.25. 24.25 meter. So our answer will be option E for question number 17. Option E. Come before this, question number 20. So question number 18. This one is a little bit, it's not easy sharp. A boat swims at 0.8 meter per second in a river flowing at 0.4 meter per second. Let's find the total time for 0.5 kilometer, that's 500 meter, upstream and back. So let's say this is a stream now. The stream is flowing like this, and the boat, this is the boat. So the boat will go like this upstream. This is upstream actually, because the river is flowing like this, only upstream. So it's going to go upstream and back. So we have to look for the total time taken. I know that velocity is, they gave us velocity, they gave us time, and they gave us distance. So we know that distance is velocity times time, right? This question is under relative velocity actually. So let's look for upstream. The time is used for upstream. As time will be the distance over velocity. So the distance it took was 500 meter, right? We have 500 meter over velocity. The velocity of the boat is 0.4 meter per second, and the velocity of the river is 0.8. So the confusion will come. The confusion that sets in is, are we going to add or are we going to subtract? Upstream, it is against the river, and the river is going 0.8. You are going 0.4. So you are going to like subtract, because it's opposing themselves. And if you remember in vector, if you have a vector like this, the vector is going like this, and another one, if they are anti-parallel, you are going to subtract. But if they are parallel, you add a vector. There's a question I solved like this in 20 questions of vector on channel. If a vector is moving anti-parallel, you are going to subtract. But if it's moving parallel, it's basic secondary school knowledge. So upstream, upstream is moving against the river, so you are going to like subtract. That will be 0.8 minus 0.4, and that will be 0.4. So 500 divided by 0.4, 500 divided by 0.4, that will be 1,250 seconds. Okay. That will be 1,250 seconds. 1,250 seconds. That's time 1. Now it has gone upstream. To go back, it has gone upstream, it has gone against the river. Now it's flowing with the river. Now the boat is now flowing with the river. So flowing with the river is still the same distance it took. So that will be 500 meter over each velocity. Are we going to add or subtract? Of course we are going to add, because it's now moving with the river. The river is flowing like this, and the boat is now flowing like this. It's no more moving upstream, it's now moving downstream. So it's moving with the river and they are parallel, so we add. So that was 0.4 plus 0.8, and that was 1.2. So we get 500 divided by 1.2, and that was 416.7 seconds. So the total time with T1 plus T2, the total time with T1 plus T2, that 1250 plus 416.7, as 1,666.7. 1,666.7, or 1.67 times 10 raised to the power 3 seconds, and that was option B. So question number 18 is option B. You can see it's easy. Upstream, if the object is moving upstream, you will subtract. Even if it's moving downstream, you add, and I've explained it, because parallel and anti-parallel, I've explained it. So question number 19. This question number 19 is not what this question. This question number 19. It said if f is 5 plus 2x, if f is 5 plus 2x, and x, if f is 5 plus 2x, find work done from x is equal to 0, and x1 is 0 to x is equal to 2 meters. So it says you find work done. I know normally we know that work is first time distance, or f dot s, but in this scenario we cannot use f dot s because it is giving true distance from here to here. So what we do in work energy theorem, we use integration. So what we do is the integral of this force. We do the integral of this force. So that will be f dx, right? So the upper point will be 2, the lower point will be 0, and the force will be 5 plus, so at least 2x, not 25. 5 plus 2x. 5 plus 2x. Can you see the board? Yes. This one is ready. And this one checking the questions. So okay, so let's integrate. If you integrate a constant, you get 5x. You get the value of variable. So that will be 20. That will be 5x plus. When you integrate this one, you get 1 plus 1 over 1 plus 1. That's 2x squared over 2. That's 2x squared over 2. 2 cancels, so that's x squared. Hope you guys understand the integration. If you want to integrate 2x, can you see the board like this? If you want to integrate 2x, what you do is just you add 1 plus 1 here. You add plus 1 here. Initially has 1 here. So you add plus 1. And you add plus 1 in the denominator too. So, because the denominator originally has 1 already. So you add plus 1. So that will be 2x. That will be 2x. That will be 2x squared over 2. Right? 2x squared over 2. And 2 cancels 2. That's x squared. So that's how we got x squared. So that will be 5x plus x squared. Now, what do? We substitute the value of x inside. That will be 5 of 2, 5 plus 2 squared minus 0, 5 plus 0 plus 0 squared. So we all know that 0, everything will be 0 like this, so everything will be 0. So 5 times 2 is 5 times 2 is 10. 10 plus 2 squared is 4. 10 plus 4, so the answer is 14. That's 14 joules. So in this kind of question, we just use integration. So that's 14 joules, and that's 19 is 8. 14 joules. The beauty of this thing is that sometimes they can repeat past questions, so you can know. So question number 20. Question number 20. They said if f that's force is 5i plus 3j plus 2k, if f is 5i plus 3j plus 2k and it moves particle p, it moves a particle to p, that's the distance. Let's represent move particle p, the distance is 2i minus j plus 0k. Then as a find work done. No work done is f dot s. So we just do the dot product. Dot product is the easiest. It's not like cross product which is math. So 5i times 2i, that's 10. 3 times minus 1, that's minus 3. 2 times 0, that's plus 0. We all know that I dot I is 1, j dot j is 1, k dot k is 1. So 5 times 2, 10. 10 times 1, 10. 3 times minus 1 is minus 3, times 1 minus 3. 2 times 0 is 0. So 10 minus 3 is 7. So the answer is 7 joules. And that's option B.